correlation coefficient is defined as the covariance between two variables divided by the product of the standard deviations. Okay, so when applied to population, generally a huge population or something like that, in which you have to find out what is the relation between two variables. For example, if I take the population of India, okay, the space, the number of houses constructed, and the food we get, how much food is available, right? So you take it that kind. When you take that kind of variables, to find a correlation between both of these, you see use a relationship, that's the Pearson's coefficient. Okay.
Okay.
Now you tell me, how do you plug it into the calculator?
How to plug it into the calculator? There are rows and columns,
Okay.
and all values for x and y are given.
Okay.
A lot of values for x and a lot of values for y are given. You just press various buttons in the calculator and you get it.
You have buttons for to find the standard deviation. It's basically used for uncertain data. Is that okay? And there's like got some plus or minus variation from a particular other thing. Now the sample he's shown here.
We did this example.
We did the worked example. Okay. So you plugged in and you got S of x, and then you got S of y, and then you found out what is R. To find out R, you can use a normal plain calculator. Is it?
No, when we do this, when we press all the buttons, all of the values are given. All of the values are given. X, S, Y, and R.
They all come onto the screen, is it?
Yeah.
Okay, good. That kind of makes things easy, right? Okay, so now you have the exercise 6.72. Do you guys start doing this?
Yeah.
Different data given here.
Yeah. Plot a scatter diagram.
On your calculator, you have to check the method given there, because I told you I'm not very familiar with the calculator. You have this.
Okay, then I have to ask that.
Oh, okay. It's given here, by the way. Which calculator are you using? KCO1?
KCO, yeah.
Okay, it's given here, see. Procedure on page 40.
Okay.
You have to plug in all the data and then you have to press F1 to plot the scatter diagram.
Okay.
You want to try that?
Yeah, I'll just get my calculator.
Yeah.
Okay, I got it.
Okay. let's go back to that example we have here.
Yeah.
The 6.7 7.2. Oh God, where did it go? Yeah, right. Page 50. The data that's given. The table below shows the height of women in an Olympic high jump event and the maximum height they jumped.
Basically, the height of the competitor is X, and then the height jump is Y.
Right.
Yeah.
So you quickly plug in these data.
Yeah. Hello? Yeah, I got the graph.
Okay. F1. Did you press F1?
Pressed F2.
F2 gives you the line of best fit. That's what he said.
Okay.
F1 gives you the scatter diagram. F2 gives you the line of the best fit.
Yeah, F1 gave me the scatter diagram. Yeah.
Good. So, what buttons do you have to calculate the mean? X and Y bar. Having some buttons there, right?
No, I calculated by myself.
Okay, you added and divided?
Added and divided.
Okay. That will give you X bar and Y bar. Okay. Now he says, the D part says, give the value of R, the product moment correlation coefficient, and moment on its value. Let's find out what's R. You say how to do it in this thing, isn't it?
Yeah.
So how much are you getting the R as?
It is 0.3.
Okay. So when you get 0.3.
Yeah.
Okay, so it's 0.3. So it's a negative or positive correlation. What is it?
It is a positive correlation.
Yeah, positive correlation. So 0.3 means it's a medium, it's not very strong. Okay?
Yeah.
0.1 to 0.3 is small, 0.3 to 0.5 is medium, 0.5 to 1 is a strong correlation. Less than 0.1 is like almost like no correlation. Okay?
Yeah.
So 0.3 means it's a medium correlation. Okay, it's not a very strong positive correlation. What does it mean? So as a person's height increases, he'll be able to jump high distances.
Oh, okay. You did that.
Yes, that's what he's asking, right? He says,
Okay.
comment on its value.
Hmm.
It's a medium correlation. It indicates that height of the competitor increases. On an average, the height jumped also increases.
Okay. Fine.